There's this idea that space is empty, but really most of the mass in the universe is invisible. There's something called dark matter, which is an unknown substance that makes up 80% of all matter in the universe. Astronomers think that this stuff could be the key to understanding how galaxies form and evolve. But what exactly is dark matter? How do we know it's there? And how does it affect galaxies? Let's take a journey to find out. Here's what we know. Stars and planets orbit around the center of a galaxy. That's because our universe has a lot of gravity. Gravity pulls things toward each other. The more massive an object, the stronger its gravity. So the stars and planets go around the galaxy's center, which has the most mass. But here's where things get weird. When astronomers look at galaxies through telescopes, they see that stars orbit in the middle of galaxies faster than they should. These are called galactic rotation curves. We can measure these by looking at how fast stars move around the galaxy. They do this by measuring how often the stars emit light as they move. Stars move toward us. Their light is blue. The stars move away from us and their light is red-shifted. From the amount of redshift or blue shift, we can calculate the star's speed. Let's look at this graph, which shows the speed of stars as a function of their distance from the center of a spiral galaxy. On this graph, the horizontal axis represents the distance from the galaxy's center. The vertical axis represents the star speed. The dots represent what we actually observe. And the line is what we expect if only gravity were acting on those stars. If a star is close to the center of a galaxy, it moves quickly because there's a lot of mass near it and strong gravity. If the star is far from the center, there's less mass nearby, so the star moves more slowly. But here's the thing. We observe stars moving around galaxies much faster than this line predicts what's going on. Well, it turns out that there's some sort of invisible matter surrounding the galaxies. This matter has gravity, and that gravity speeds up the stars. To explain this phenomenon, astronomers have proposed that galaxies are surrounded by a giant sphere of dark matter. This dark matter would make up about 80% of the matter in the galaxy, but it wouldn't interact with normal matter or light, so it would be completely invisible. How do astronomers know this dark matter exists? Well, not directly. It's like you're on a merry-go-round and you feel yourself being pulled outward. You know something is there, but you can't see it. Here you can see the effects of the dark matter on the galaxy, but you can't see the dark matter itself. So why do astronomers think there's a dark matter halo? Because the observed rotation curves of galaxies require something like 8 times more mass than we can actually see. Where could this extra mass be? Well, one possibility is that it's spread throughout a large region outside of the galaxy. If this is true, then the amount of gravity from the dark matter would depend on how far away it was from the stars. Dark matter that is far away would have a weaker gravitational pull than dark matter that is close. So just like in Newton's thought experiment, the farther away the dark matter is from the center of the galaxy, the slower the stars would move. But observations show that the stars move faster than this, so there must be more dark matter closer to the center of the galaxy. It's like when you play a game of tug-of-war. If one team has twice as many people on it, then it will win every time. However, if the team with twice as many people spreads out its players along the rope, then the other team can pull them closer to the center of the galaxy. In this case, the team with twice as many people represents the dark matter. The more evenly distributed the dark matter is, the faster the stars will move. So astronomers conclude that the dark matter in galaxies is concentrated in a thick disk around the center. This is called a dark matter halo. The idea that galaxies have dark matter halos has been around since the late 1930s, but it was until the 1970s that Fritz Zwicky first proposed that there might be a more exotic kind of matter in the universe, a kind that did interact with normal matter or light. He called this dark matter. Now, it's important to remember that dark matter is different from dark energy, even though they both have the word dark in them. Dark energy is a hypothetical form of energy that is thought to permeate all of space. It's the stuff that's causing the expansion of the universe to speed up. We don't know what dark energy is, but we know that it doesn't clump together like normal matter does. If dark energy existed inside of galaxies, it wouldn't have any effect on the way that they rotate. By studying the rotation curves of galaxies, astronomers hope to learn more about dark matter. For example, by measuring how fast stars move around a galaxy, they can use that to infer how much mass is in the dark matter halo. By studying how galaxies rotate, astronomers can also learn about the distribution of dark matter in the universe. The more massive a galaxy is, the more dark matter it has, and the more massive a galaxy is, the faster it rotates. One of the coolest things about studying dark matter is that it gives us a window into the fundamental nature of reality. We know that the universe is full of stuff we can't see. There are a lot of things out there that we don't understand yet, but as we continue to explore the universe, we'll learn more about what's out there. And while we may never see dark matter directly, it's still out there. It's holding galaxies together, keeping them from flying apart. And without dark matter, the universe wouldn't be the same. I hope you enjoyed learning about dark matter in galaxies. If you did, please follow for more videos like this one. And if you want to learn more about the universe, check out our website. We have a ton of great articles there that I think you'll enjoy. Thanks for watching. I'll see you next time.